In a previous lesson, we multiplied pairs of binomials, and the result was often a trinomial such as this one. In this lesson, we're going to look at trinomials and see if there's a way to figure out if the trinomials we're looking at are the result of the product of a pair of binomials. Well, the first thing we're going to do is take the 12. And we're going to ask ourselves, what are the factors of 12? Well, 1 times 12 makes 12, 2 times 6 makes 12, and 3 times 4 makes 12. Well, the reason we did that is because 3 plus 4, circled, also adds up to 7, the coefficient of x, the middle term. So the factored answer here is the binomials x plus 3 times the binomial x plus 4. Because if you multiply those two to check your work, you realize that, of course, x times x is the x squared. The x times the 4 is a 4x. The 3 times the x is a 3x. And the 3x and the 4x is where we get our 7x. And, of course, the final two terms, the 3 times the 4 makes 12. Similar problem, only instead of 7x, it's 8x. But 6 plus 2 makes 8. So for this trinomial, it's the binomial x plus 2 times the binomial x plus 6. And here's one where the middle term is 13x. And of course, that's 1x plus 12x makes 13x. So our two binomials are x plus 1 and x plus 12, because 1 times 12 is 12 and 1 plus 12 is 13. But here's one with a 9. And none of those pairs of numbers add up to 9. So this trinomial is not factorable, or we say that it's prime. Not all trinomials can be factored. Here's one where the middle term is being subtracted. But that's okay. Negative times negative makes positive. And in this case, positive 12. So all of our factors have become their opposites. And we're looking, of course, for the negative 3 and the negative 4 because they make positive 12 when multiplied and negative 7 when added. So there's our two binomials that multiplied together to make the trinomial at the top. The binomial x take away 3 times the binomial x take away 4. Now we have the 12 negative. This adds a little ripple to what we're looking at. Notice our chart's bigger because the 1 can be negative and the 12 positive, or the 1 positive and the 12 negative, and the same with the other two pairs of numbers. So now instead of having just 3 pairs of numbers, we have 6 pairs of numbers because one of the numbers has to be negative and the other positive. So each one of those pairs of numbers multiplies to make negative 12, and one of those pairs of numbers adds up to 4, and that's the negative 2 and the 6. So our binomials are x take away 2 and x plus 6. And of course, if the 4x is negative, or in this case subtract 4x, we use the bottom pair because 2 plus negative 6 is negative 4, and 2 times negative 6 is still negative 12. So there's our pair of binomials. So again, what we've done is we've taken a trinomial and factored it into a product of a pair of binomials. And here's one. And of course, 12 plus 1 is 13. But if one of the numbers is positive and one is negative, we can never get negative 13. We can get negative 11, but there's no negative 13. So this one's prime. Now here's one we can do in our head. 15 is either 15 times 1 or 3 times 5. And since 3 times 5 is 8, we don't need to show a lot of work here. We can just write it down, and there it is. And here's one where the 8's negative. But because the 15's positive, we know that it's negative times negative to make positive, so it's still 5 and 3. Or in this case, it's negative 3 and negative 5. Or as we write it, x take away 3 times the quantity x take away 5. And if we have a 2 and a negative 15, it's a little more complicated, but we can still mull it over in our head. 1 times 15 is 15, and 15 minus 1 is 14. 3 times 5 is 15, and 5 take away 3 is 2. So that's the one we're going to use. It's x take away 3 and x plus 5, because the negative 3 and the 5 makes the negative 15, and the 5 and the negative 3 makes the positive 2 and the 2x. So there's our factored answer. And here's one with a prime number as the third term. The only way to do 23 is 23 times 1, so it either works or it doesn't, and it does, so there's our factored answer. And here's one where the middle term and the third term are both negative. So as we look at 23, it's either going to be 1 times negative 23 or negative 1 times positive 23. And of course, since the 22x is negative, we have to use positive 1 and negative 23. So there's our binomials. X plus 1 is the first binomial, and x minus 23 is the second binomial. And here's one a little more complicated because 72 has lots of factors. But if you're good with your times tables, you can probably do it in your head. It's okay to do a little scratch work because you may not have your 36s, your 24s, and your 18s memorized. But if you work with it a little bit, you realize that 4 times 18 is 72, and 4 plus 18 is 22. So those are the two factors of 72 that we're after, and they work for this trinomial. So there it is, the binomial x plus 4 times the binomial x plus 18. In this lesson, we have factored trinomials in the form ax squared plus bx plus c. But for this lesson, a has always been 1. To do this, find a pair of numbers m and n such that the product of m and n is c and the sum of m and n is b. If no such numbers exist, then the trinomial cannot be factored, and we say that it is prime.